Well, welcome back. Now we're in section 3.2, focusing on inverse functions and logarithms. Now, again, as I mentioned to you guys before, the chapter 3.1 and 3.2 tie in a little bit of calculus with a wee bit of exponential and logarithmic and inverse function review stuff. So our focus on when we cover as professors 3.1 and 3.2, we're focusing on the calculus and the limit and eventually the derivative concepts. A lot of the definition of using exponentials and logarithms and solving equations, we are expecting you guys to go back and review on to make sure you guys are well versed. So here's another example of me kind of helping you guys out. A little bit of review, and then we're going to focus on some log properties, and then we're going to actually focus on some limits of the logarithms, which is what our focus on section 3.2 is going to be on. So let's start this one out. All right, for the function f of x equals 3x plus 1 divided by 2x plus 4. We want to find the inverse function, f inverse of x, if it exists. So the proper steps that you need to go through to figure out if a function has an inverse function is this. Step 1. You got to make sure f of x is 1 to 1. Now, 1-to-1 function. A 1-to-1 function means that for every x you have an input, there's going to be a unique y as an output. We used to check this by something called the vertical line test. So to test to make sure that you have a 1-to-1 function, because only 1-to-1 functions have inverse functions, I'm going to come over here to my calculator, and I'm going to graph this guy. Now the function is 3x plus 1, notice the wonderful use of parentheses around the numerator, divided by 2x plus 4. Now I'm just going to do a zoom standard on it. And here is my graph. Now, to make sure a function is 1-to-1, we're going to do the vertical line test. So any vertical line only intersects this graph in only one spot. Any vertical line you create, it'll only intersect it at one spot. So by our vertical line test, this thing is 1-to-1. So 1-to-1 function, check. So then the next thing you want to do is step 2. Step 2 is replace your function with y. It just helps you out with the math. So that's going to give me the equation y equals 3x plus 1 divided by 2x plus 4. Step 3, switch the x and y. This right here, step 3, actually is the idea behind inverses. Switching the x and y, switching the independent and dependent variable. So when I switch x and y, it's going to give me the equation x is equal to 3y plus 1 divided by 2y plus 4. Now, step 4, solve for y. So we picked a harder one to solve for because I got y's on the numerator and the denominator. Well, the first rule on solving for a particular variable, and when you got fractions, is to get rid of the fraction. So now here's the algebra. To solve for y, I'm going to multiply both sides by my denominator, 2y plus 4. What I do to one side, I do to the other, 2y plus 4. This is going to give me x times 2y plus 4 equals, over here on the right side, 3y plus 1 divided by 2y plus 4 times 2y plus 4. Well, the 2y plus 4s will cancel, aka I'm getting rid of my denominators, no more fractions. Next thing I want to do is get rid of parentheses. After I get rid of my fractions, my denominators, I want to get rid of parentheses. So I'm going to get rid of parentheses by distributing. This gives me 2xy plus 4x equals 3y plus 1. Now keep your eye on the ball. We're trying to solve for y. If I'm trying to solve for y, I want to get all the y terms on one side, all the terms without y on the other. Who's got a y in it? Well, I got a 2xy there, and I got a 3 times y there. These are my y terms. So I'm going to subtract 3y on both sides, get my y terms together. And at the same time, I'm going to subtract 4x to move that non-y term over to the other side. So here the 3y's will cancel, and the 4x's will cancel, but that would leave me with 2xy minus 3y equals negative 4x plus 1. All I've done, honestly, is juggle my equation to get all the terms with y on one side, all the terms without y on the other. Now, here's the big deal. I got multiple terms with y in it. That's going to happen to you. When you have multiple terms with y in it, do the big factor. Factor out the y. That's going to leave you with 2x minus 3. That's still equal to negative 4x plus 1. So the big trick at this point, when you got multiple terms with y in it, is factor out the y. Now, solving for y, I'm going to divide by 2x minus 3 on both sides. And that's going to give me y equals negative 4x plus 1 over 2x minus 3. So, step 1, make sure you have a one-to-one function. And typically, graph it, make sure it passes the vertical line test. Any vertical line should only intersect the graph at one spot. After it is a one-to-one function, because only one-to-one functions have inverse functions. Step number 2 is replace f of x with y. So I replace my function with y. Step number 3 is where the inverse comes in at. You switch the x and y coordinates. So instead of y equals 3x plus 1 over 2x plus 4, then when you switch it, you'll get x equals 3y plus 1 over 2y plus 4. Switch the position of the x and y's. And then you got to solve for y. That requires the algebra. Then you got one more step. Step number 5. You are going to replace the function, in my case, f of x, with the inverse notation. F with a little minus 1 of x. That's f inverse. So you now have the inverse function. So my solution is f inverse of x is equal to negative 4x plus 1 divided by 2x minus 3. And there is my solution for f inverse. Now, that being said, the next concept with these inverses and why the inverses show up in this chapter is logarithms. Remember, logarithms are the inverses of exponentials. They cancel out the exponential. You know, when you need to kill off an exponential, you use a log. You have a log, you do the exponential to both sides to get rid of the logs. But we do have log properties. And again, this is, the review that we're focusing on here. So my log properties are the big three right here. Log base b of m times n is equal to log base b of m plus the log base b of n. Log base b of m divided by n is the log base b of m minus the log base b of n. And the log base b of m raised to the n is equal to n times the log base b of m. In other words, with logarithms, multiplication turns into addition, division turns into subtraction, and powers get to go out front. So the log base b of m to the n gets to go out front of the log base b of m. Okay? So these are my big three log properties. They are very beautiful properties. And let me explain why. We're going to be doing derivatives later on. You know we're setting you guys up for more calculus here. We've done quite a bit of review and talk about limits with this stuff. But the big deal is this. 'Tis better to do calculus on easy stuff than it is to do it on hard stuff. So when I got a problem like this, I got the log of 1,000 times x to the 4th times the square root of z divided by y plus 5 squared. And I want to basically do some kind of calculus on this thing. Before I do any calculus, I would like to simplify it first. Simplify is take this one huge log and bust him up into multiple logs, aka simplify the expression. Now, what base is understood to be on this log? We didn't write a base. It is understood to be base 10. Just remember that. But first off, let's do our log properties. Log property says multiplication turns into addition and division turns into subtraction. So this log of 1,000 times x to the 4th times the square root of z divided by y plus 5 squared. And what's in the numerator is being multiplied. Multiplication turns into addition. So this will be the log of 1,000 plus the log of x to the 4th plus the log of z, square root of z. But this division, things in the denominator are turning into division. This will be minus the log of y plus 5 squared. Multiplication turns into addition, division, and remember, anything in the denominator is being divided. If you got it in the denominator, it'll be a minus and turns into, like I said, division turns into subtraction. But we're not done yet cleaning this guy up. First, I don't do square roots. Remember, square root is a half a power. So we don't do square roots. That's square root of z is the same thing as z to the half. And thanks to log property number 3, where do powers get to go if I want to simplify it? So when I have a term to a power, powers get to go out front. So this is equal to the log of 1,000, plus 4, the exponent pops out front, the log of x, plus 1/2 the log of z, minus the 2 pops in front of the log, 2 log of y plus 5. Okay? There's my answer, but we can clean it up a little bit more. Now, what is the base in terms of these logs? It's understood to be 10. When we don't write a base, it's understood to be a common log, base 10. But we got 1,000 right here, and we can clean that number up. 1,000 is the same thing as 10 cubed. 100 is 10 squared. 1,000 is 10 cubed. So this is the same thing as log of 10 cubed plus 4 log of x plus 1/2 log of z minus 2 log of y plus 5. And remember the old properties here. The log of base a of a to the x is equal to x. That's understood to be a base 10, even though we don't write it down there. This is 10 to the 3rd power. They'll cancel, and you're left with just the exponent. So the answer is 3 plus 4 log of x plus 1/2 log of z minus 2 log of y plus 5. And there's my solution. And before we move on to the next problem, one other common mistake people make, students make, is trying to distribute a log over a plus or a minus. That is illegal because the property says addition can turn back into multiplication, subtraction turns back into division, but you cannot distribute logs. So there's the old John rule here. The log of m plus or minus n does not equal the log of m plus or minus the log of n. Don't make that mistake. You can't do this. You can't distribute logarithms. That is illegal. So remember this. So this is the best way this answer is going to look. All right, well, let's keep moving on. Over here, I consider these log problems the Humpty Dumpty kind of problems. We take Humpty Dumpty, we bust him up into 1,000 pieces, and then it's our job to put him back together again. So here we go. Let's put him back together again. Write 4 log x plus 1/2 log z minus 2 log of x plus 3 plus log of 8 as a single logarithm. So we got these guys in multiple logs. They're all the same log, and it's understood to be log base 10 again because we don't have a base on those logs, and we want to put him back together again. So let's just rewrite the problem. This is 4 log of x plus 1/2 the log of z minus 2 log of y plus 3 plus the log of 8. Now, to combine logs, again, this is working backwards. So to combine logs, addition turns back into multiplication, subtraction turns into division, and powers out front get to go back in the exponents. And remember, before you can use these properties here, understood that the coefficient in front of the logs are always 1. So anytime there's a number in front of your log, you had to go back where you came from, which is the exponent. So my first move here is to get rid of these coefficients in front of the logs, and they'll go back as exponents. So this turns into the log of x to the 4th plus the log of z to the half minus the log of y plus 3 squared. The 2 goes back into power, and this is just a constant log of 8. And notice, to combine logs, they all have to be the same log, and this is one big logarithm, understood to be base 10 because I didn't write a base down there. So here's the deal. Addition turns back into multiplication. Subtraction turns into division. And the rule of thumb is if it's positive, it goes on top. If it's minus, it'll go on the bottom. And it doesn't matter about order. This is positive, so the x to the 4th is going to go on top. This is plus. Plus into multiplication. Multiplication turns up in the numerator, so the z to the 1/2 will show up on top. This is a minus. Minus means turns into division, so the y plus 3 squared will show up in the denominator. but this is a plus. That means it's multiplied. Multiplication means the terms show up in the numerator. So the 8 will show back up in the numerator. Now, if we wanted to clean this up for that proper answer, my answer would be the log of, it looks better to write like this, 8 times x to the 4th times the square root of z divided by y plus 3 squared. And there's my solution. Okay, so remember what I said about if it's positive, it shows up on top. If it's minus, it shows up on bottom. Because addition turns back into multiplication. That means it's going to be in the numerator. Subtraction turns into division. Division goes into the denominator. Now, let's talk about these guys in terms of log properties. Your log properties when it comes to limits. Now remember, your natural log is the same as a log, but it's understood to be base e, that 2.718 number. So this is log base e. So when I take the limit as x approaches 0 from the plus side of the natural log of x, I get negative infinity. When I take the limit as x approaches infinity of the natural log of x, I get positive infinity. And it comes from the graph of y equals the natural log of x. You can only take the log of positive numbers, and this is what my log graph looks like. So I'll get close to 0 there. I'm going to negative infinity. As x goes to positive infinity, it blows up, it goes to positive infinity. I'll let the autofocus take over here. Now, same idea here, whether it's a natural log or a common log or any base, as long as the base is bigger than 1. So I'm going to put little a's down here for a base. As long as the base is bigger than 1, then take the limit as x approaches 0 on the plus side of log base a of x, I get negative infinity. And when I take the limit as x approaches infinity of the log base a of x, I get positive infinity. Again, the graph looks exactly the same for any log base a, as long as the base is bigger than 1. So same reasoning. So let's do this problem here. Take the limit as x approaches infinity of negative 2 times the natural log of x plus 3 divided by 5. Well, again, the first rule of limit is plug in a number. So this will be negative 2 times the natural log of infinity plus 3 over 5. But what is that natural log of infinity? When I take the limit as x approaches infinity, the natural log of x, what do I get? I get infinity. So this will be negative 2 times infinity plus 3 divided by 5. Now from this point on, you got to follow your nose. Follow the basic math. This is positive infinity. If I take positive infinity and multiply it times negative 2, that's going to give me negative infinity plus 3 divided by 5. Let's finish up the math. If I take negative infinity, something really large negative, which makes it really, really small, add 3 to it, it's still negative infinity. And a negative infinity divided by 5, divided by a positive number, negative really big divided by 5 is still negative really big. And the answer is negative infinity on this problem. Just follow the signs. Okay? Try this one. Take the limit as x approaches 0 from the plus side of the natural log of x plus 3 times x minus 2 divided by 4x squared minus 3. First rule of limits, plug in a number. This will be the natural log of 0 on the plus side plus 3 times 0 on the plus side minus 2 divided by 4 times 0 on the plus side squared minus 3. So I wanted you to see, literally, I'm just plugging in a number. This is how you play the limit laws. First rule of limits, plug in a number. But then you got to know some stuff. Here it is. What is the natural log of 0 on the plus side? Well, when I take the limit as x approaches 0 on the plus side of the natural log of x, I get negative infinity. So this is going to be negative infinity plus 3 times 0, that's 0, minus 2 divided by 0 squared, well, that's 0, so this is 4 times 0 minus 3. I'm doing it for this long way for your benefit because I want you to see I'm doing one step at a time, not skipping any steps. So this is equal to negative infinity plus 0 minus 2 is minus 2. 4 times 0 is 0 divided by negative 3. And at this point, it's following your nose. What's negative infinity minus 2? Minus 2 more from a negative infinity is still negative infinity. Divided by negative 3. Infinity is on top. The answer is going to be infinity. But what's the signs? Negative infinity divided by negative 3. Well, a negative divided by a negative is a positive. Infinity divided by 3 is infinity. The answer is positive infinity. So with a lot of these answers, you get 0, infinity, negative infinity. And we'll get some numbers like 3/5 and 4/3 and stuff, but you got to follow your nose. We're trying to get you guys to actually see the algebra. Hope this has been helpful, and look forward to seeing you guys on the next video. See you guys then.